Hey, Doxig here to talk about crossover method with ionic charges and explain the math that justifies the method. So the biggest question I get, why do we do crossover method for ionic compounds? Simple. We need to neutralize the two ions when they come together in the formula. Crossing the charges results in the superscripts crossing over and becoming subscripts. It's really important that you do not bring the signs down. The positive and the negative, do not bring them down, only the charge number. So let's look at the formula. The charge of the ion times the subscript that came over, plus the charge of the ion times subscript equals 0. Let's go ahead and work through 5 equations to show the math and justify why we do crossover. Starting with Na plus Cl minus. Positive 1 times the 1 that came from the chloride plus negative 1 times 1. So we would wind up with plus 1 plus negative 1 is 0. Neutral charge. Math checks out. Na plus S minus 2. Plus 1 times 2, the 2 coming from the sulfur, plus negative 2 times 1. We wind up with plus 2 plus negative 2 is equal to 0. What about iron 3 sulfide? Fe plus 3 plus S2 negative plus 3 times 2 plus negative 2 times the 3 equals 0 because we have plus 6 plus negative 6. Ba plus 2 plus N negative 3 plus 2 times 3 gives positive 6 plus negative 3 times 2 gives us negative 6. So positive 6 plus negative 6 is 0. Last one I'm going to show the math for. Ni plus 2 plus PO4 minus 3. Look, this even works for polyatomics. Let's go into the math. Positive 2 from the nickel times the 3 from the phosphate plus negative 3 on the phosphate times the 2 from the nickel crossover gives us plus 6 plus negative 6 equals 0. So now you can see the crossover method is justified with the math. I'm just going to give you a few more examples of crossover and how it's done, using individual ions to make the formula. Ti plus 4 plus O2 minus. Ti, the plus 4 is going to cross over to the oxygen. The negative 2 on the oxygen is going to cross over between the Ti and the O. We can simplify this by dividing both by 2, and we wind up with TiO2. NH4 plus 1, O minus 2. If it's a polyatomic and the charge is going to be greater than 1, we have to protect it with the parentheses. So NH4, put that in parentheses, 2O. Cu plus O2 minus. The positive 1 from the copper is going to cross over to the oxygen. The 2 from the oxygen is going to cross over in between the copper and the oxygen, and we would wind up with Cu2O. Ca plus 2 plus NO3 minus 1. The positive 2 from the calcium is going to go on the other side of the polyatomic. So we're going to need a parentheses to protect that polyatomic. And then the 1 from the polyatomic comes in between the Ca and the NO3, but we don't write ones, they're implied. So we would have Ca parentheses NO3 parentheses 2. Make sure you're writing those crossover charges as subscripts. Really important, by the way. Pb plus 4 plus CO3 minus 2. The 4 from the lead crosses over to the polyatomic, and the 2 from the polyatomic crosses over between the lead and the CO3. And so we would get Pb2 parentheses CO3 close parentheses 4. We can divide both by 2, so we wind up with Pb parentheses CO3 close parentheses 2. Let's look at tin 4 sulfate. So Sn plus 4 plus SO4 2 minus. The charge on the tin, the positive 4, crosses over the SO4, and the 2 from the SO4 polyatomic goes in between the tin and the SO4. We would get Sn2 parentheses SO4 close parentheses 4. Simplify it, divide both by 2. We get Sn parentheses SO4 close parentheses 2. Li plus CO3 2 minus. The positive 1 crosses over. The negative 2 crosses over, gives us Li2 CO3. Remember, we don't have to put a parentheses on the polyatomic if it's 1. Anything greater than 1, yes, parentheses always. Mg plus 2 plus F minus, we would wind up with Mg F2, Al positive 3 plus P minus 3. Cross them, and we divide them by both 3, simplify them, so we just get ALP. K plus CrO4 minus 2. Cross those charges, we get K2CrO4. All right, I wanted to also throw in, if you have the formula, how to uncross them, because this sometimes is the problem for most students. We have Ag2S. Cut it right between the two elements, so Ag, and then we'll write the S. I know sulfur has a -2 charge because of the group it's in. You can refer back to one of my other videos for this. I'll link it right here in the corner. But I also know silver, it's a charge you have to remember. Again, in the same video, is a positive 1. So I wind up with Ag positive 1, S to the -2. K2CO3. Cut it between the K and the CO3. Separate them. So I get K plus CO3 2 minus. That's a polyatomic. You can always check yourself. If you don't have the polyatomics memorized, you can always refer to the table to check yourself out. But you also know that K, because the group it's in, is a positive 1. So you can uncross those and what you get, which would be the K plus CO3 2 minus. Fe parentheses NO3 close parentheses 3. Uncross them. That 3 came from the iron, so iron plus 3, NO3 minus 1. That polyatomic. And you're noticing when I uncross these, just like in the formula, cation's always first, and then it's the anion. Always. NiS. Hey, there's no charges. They have to be the same charges. We know sulfur is -2, so that means the nickel is a positive 2. BaI2. On cross, Ba, I know iodine. I know it's -1 charge. I know Ba, positive 2 charge. Easy. Al, parentheses OH, close parentheses 3. That 3 comes from the aluminum. It's one of those charges to remember, Al plus 3. The hydroxide's a -1. That's on that polyatomic. ZnSO4. Separate the zinc from the sulfate. Zinc's one of those charges to know and memorize. So Zn plus 2, polyatomic SO4, -2. Also, I would know that they're the same charges because there's nothing in between them. There's no parentheses on the polyatomic. So like charges, when they come together, right, you know they're exactly the same. NiBr2. Separate NiBr. I know Br is a -1 charge. So that 2 comes from the nickel when I uncross them. CuSO4. Separate. Write the CuSO4. I know the charge in the SO4 is -2. Because there's no parentheses around the SO4, it means the copper has the same charge, plus 2. Ag3N. Silver. Ag plus 1, I know that charge is 1 to know. And I know nitrogen charge is a -3 because I know where the group of the family is. I know the ionic charge affiliated with it. Mn parentheses Cn parentheses 2. Separate them. Nn positive 2. I know the polyatomic charge on cyanide Cn is a -1. This last one often throws students for a doozy. It's easy though. We're going to separate silver. We know that charge. It's one that we know and memorize, Ag plus. And that means the rest of that, C2H3O2, is a -1 charge. There's no parentheses around the polyatomic, so it's the same charge as the silver. Just a few more to go. Here we go. Cu, parentheses C2H3O2, close parentheses 2. We're going to separate it. We'll have the copper, and then we have the C2H3O2. That 2 came from the copper. We know the polyatomic has a -1 charge when we uncross them. Ni parentheses MnO4, close parentheses 2. That 2 came from the nickel, so positive 2. And there's nothing between those two, so that means that the MnO4 has a -1 charge. Sn parentheses Cr2O7, close parentheses 2. Let's first separate them, so Sn, and then write Cr2O7. Well, we know that that polyatomic has a -2 charge, so that means the tin had to have a +4 charge, and it was simplified. Don't let that catch you. Fe2, parentheses SO4, close parentheses 3. Uncross them, so we'd have Fe plus 3, and that -2 for the SO4, so that 2 between the Fe and the parentheses on the polyatomic came from that SO4. All right, that's it. That's how we uncross on ionic formulas. and the math that justifies the crossover method. Until next time, see you later.